Welcome back, friends. In the previous session, we discussed about the concept of standard electrode potential, and in this session, we are going to discuss about the electrochemical cells. Electrochemical cells is the device that produce electric current from redox reaction, oxidation, reduction reaction. So it produces electric current or it produces EMF from redox reaction. In this topic, we said from before that it is called electrochemistry. That means we are looking at how the chemical energy can be converted into the electrical energy. The energy which is involved with the oxidation reduction reaction is used to drive or is used to cause the motion of electron and thus the flow of electric current. That's why it is called as an electrochemical cell. So it produces electric current from redox reaction, yani oxidation reduction reactions. The most well-known electrochemical cell is galvanic cell or volcanic cell. Na ndio ambayo tutakuwa tunaidiscuss hiyo galvanic cell. So there are many categories of electrochemical cells, but for our case we'll be discussing about the galvanic cell, and we will go deep to start about this galvanic cell and to see different things regarding the galvanic cell. A galvanic cell, also called the voltaic cell. Galvanic cell or voltaic cell is the device that uses spontaneous oxidation reduction reaction to produce electric current. So each kifaa is just the device that uses the spontaneous oxidation reduction reaction to produce electric current. Spontaneous oxidation reduction reactions to produce electric current. Note that a spontaneous reaction is the reaction that runs without any application of external energy. So these reactions, they don't have application of any external energy, and thus because they don't have the supply of external energy, that's why they are categorized the spontaneous reactions. They are categorized the spontaneous reaction. Sasa galvanic cell huwa inakuwa na parts ambazo we must discuss about them. The first part is anode. Anode is an electrode where the oxidation reaction occur. Is an electrode where oxidation reaction occur. Remember, the oxidation reaction, that means we are taking a metal, then we get a metal ion plus any electron. This is oxidation reaction. So oxidation reaction occurs at anode. Then we have cathode where reduction reaction occur. Reduction reaction occur at cathode. So anode is an electrode where oxidation reaction occur. Cathode is an electrode where reduction reaction occur. Voltmeter is the device which measures the cell potential and EMF. We know from two current exist. Two half cells. A half cell is an electrode in contact with its electrolyte. Half cell in electrode ikiwa in contact with its electrolyte. Haya, hiyo ni half cell. In one half cell oxidation occurs, while in other half cell reduction occurs. Kwenye half cell moja oxidation inatokea, kwenye half cell nyingine reduction inatokea. Lakini number 5 we have the salt bridge. Moja kati ya kitu kinaitwa salt bridge. A salt bridge is an inverted U-tube containing an inert paste of a strong electrolyte such as a potassium nitrate, potassium chloride, sodium sulfate, and agar gel. Kwa hiyo tutaenda kuona kwenye diagram ya electrochemical cell. Tunakuwa tuna cell moja huku, tunakuwa tuna half cell nyingine huku, na tunakuwa tuna electrode. Ila baada ya kuwa na electrode tunakuwa tuna kitu ambacho kinakuwa kiko hapa, kinaitwa salt bridge. Ndani tunaweka strong electrolyte pamoja na agar gel. Kwa kunakuwa kama kuna uji fulani mzito unakuwa ndani. But materials which are packed inside this, they allow the passage of ions from this solution to this solution, or from this solution to this solution. A salt bridge is an inverted U-tube containing an inert part of a strong electrolyte such as this one, or this one. Now kumbuke hiyo ni inert, then with agar gel. Inert, that means it does not react. So the solution in two half cell or compartment are connected by salt bridge. Kama ambavyo ni kucholea hiyo diagram, lakini pia tutaenda kuona diagram nyingine. So a salt bridge provide a passage to ions, from one compartment to the other compartment without intensive mixing of the two solution. That's why nilikwambia kwamba salt bridge kama hii inaruhusu ions zitoke huku ziende huku na huku ziende huku, lakini solution mbili hazijimix. They don't mix, but the ions they move. So with this flow of ions, the circuit is completed and the electrons pass through the wire from anode to cathode to keep the net charge zero in the two compartment. Kwa bila salt bridge manake circuit isingekuwa completed, ingekuwa haiwezekani kuflow umeme humo ndani, sababu electrochemical cell zinakuwa zina compartment mbili tofauti, negative compartment kivyake na positive compartment kivyake, yani the half cell ya kwenye anode kivyake na half cell ya kwenye cathode kivyake. Hasa kama ni tofauti na zile electrolytic cell ambazo zinatumika kwenye electrolysis, ambazo zenyewe both electrodes they are dipped in one solution, but here two electrodes they are dipped in two different solutions. So the significance of the salt bridge: first, it allows ions to migrate from one compartment or half cell to another. So as to complete the circuit. This helps to maintain the electrical neutrality in the two compartments of the electrochemical cell. Kwa hiyo inafanya two compartments of electrochemical cell become neutral. Huku na huku balance, they become neutral. And number two, prevents the diffusion of electrolyte from one half cell to the other. Prevent the diffusion electrolyte from one half cell to the other, thus maintaining charge balance in two half cells. That means kama tungeweka tu ile inverted U-tube bila kuweka zile materials zetu, manake kungekuwa kuna passage of ions ambayo ingesababisha diffusion of electrolyte and thus mixing of the solutions. Lakini here ina prevent diffusion of electrolyte. That means only the ions they are passing, but the whole electrolyte does not diffuse. The ions they are passing simply to maintain the electrical neutrality and to cause the flow of electric current through the voltmeter. So one thing to note is that if no salt bridge were present, the solution in one half cell would accumulate negative charge. If no salt bridge were present, the solution in one half cell would accumulate negative charge. Ingekusanya negative charge. And the solution in the other cell would accumulate positive charge. And the reaction proceed, quickly preventing further reaction, and hence production of electric current will be affected. Kwa hiyo kama kungekuwa kuna salt bridge, maana yake ni kwamba hizi reaction zingekuwa stopped faster sana kwa sababu ya accumulation of negative charge and accumulation of positive charge into different electrochemical cells. The agar gel in the salt bridge help to prevent the intermixing of electrolyte which might otherwise occur. Manake tusingeweka agar gel, intermixing of electrolyte ingekuwa inatokea, electrolyte zingekuwa electrolyte zingekuwa zina mix, lakini otherwise there is no need of having the agar gel. So from there, let's have another definition, which is electrolyte is the substance that give free ions either in molten or in aqueous solution. Either in molten or aqueous solution. The electrolyte can be anolyte or catholyte. The anolyte is electrolyte at anode half cell, in which the anode electrode is dipped, while the catholyte is an electrolyte at the cathode half cell, in which the cathode is dipped. It is known as the catholyte. So electrolyte inakuwa na free ions either in aqueous or in molten state. Free ions is the basic characteristics of electrolyte. Then you have the external wire. External wire, this allows the flow of electrons from anode to cathode. Note that in electrochemical cells or galvanic cell, anode is negative and cathode is positive. Anode is negative and cathode is positive. Conventionally, it has been agreed that anode or oxidation half cell must be kept at the left hand side, while the cathode yani reduction half cell must be kept at the right hand side. Anode inatakiwa iwekwe kushoto, cathode kulia. So hivi ndivyo ambavyo electrochemical cell itakuwa inaonekana. Here we have the salt bridge. Haya, hapa tuna external wire. Electron zina flow kutoka kwenye negative kwenda kwenye positive. Alafu current ina flow kutoka huku kwenda huku, kwenye positive kwenda kwenye. Kwa hiyo kinachokuwepo hapa ni kwamba hii inakuwa ni anode, cathode, electrolyte, anolyte, catholyte, salt bridge, voltameter ile pale. Hivi ndivyo ambavyo electrochemical cell inakuwa. Electrochemical cell inakuwa kama hivyo hapo. Kwa hiyo to the left is an anode which is negative charge, to the right the cathode which is positive charge. So in the coming session we discuss about the construction of electrochemical cell from given standard electrode potential. Thank you, and later we wish you nice studies.